Welcome to our STEM Lyceums Nuclear Engineering event. My name is Laura Ashley. I am the Program Manager for STEM Lyceums at CEE, and I'll be hosting today's event. As people join, I'll just talk a little bit more about the center. CEE is a nonprofit organization that was founded in 1983 by Admiral H.G. Rickover, which you'll hear a little bit more today in both of our speakers' presentations, who is the father of the nuclear navy and civilian uses of nuclear power, and the co-founder, Joanne DeGennaro, who is CEE's president. CEE has a mission to nurture high school and university students to careers of excellence and leadership in STEM, and also encourages collaboration between and among scientific and technological leaders in the global community. This is STEM Lyceum. STEM Lyceum is a CEE program with a mission to engage high school students in discussions and exploration of STEM concepts and STEM career pathways. So for today's event, the theme is nuclear engineering. And I am excited to introduce our two speakers for today's event. We have Robin Penley and we have Dr. Neil Todreas. So I'm going to tell you a little bit about each of them. Robin Penley is the lead research engineer for modeling, simulation, and analysis at Newport News Shipbuilding. She's a graduate of Old Dominion University with a degree in mechanical engineering, and she has more than 30 years of experience in engineering, shipbuilding standards development, and software integration and development. I'm also pleased to introduce Dr. Neil Todreas, who is a nuclear engineering professor at MIT. He has extensive nuclear power experience and served on the U.S. Nuclear Regulatory Commission's Reactor Safety Research Committee. In addition to his part-time teaching and research, Dr. Todreas continues to be a leading consultant to industry and government. He is a fellow at the Emeritus Society of Mechanical Engineers and a member of the National Academy of Engineering. So I will turn things over to Robin Penley.
Good afternoon, everyone. My name is Robin Penley. I work at Newport News Shipbuilding. I am a level 5 technical engineer, which means I have expertise in a certain area. There aren't a whole lot of level 5 engineers at the shipyard. My expertise is modeling and simulation. So I'm just going to go tell my story here, my STEM journey. So I'm going to weave the story of cats because I love cats. And even as a little girl, you know, I had cats. So I know what does cats have to do with what my story is, but I'll weave it in, you'll see. But what I've noticed looking back, reflecting, is that I've had role models in my career here. And I didn't realize that at the time, but once I went back and was presenting this, was getting ready for this presentation, I realized I've had a lot of people in my life that have believed in me and helped me out through my career. And I really didn't realize it at the time. And as I was looking through this, I'm like, you know, there are people that believe in you, and that helps so much. So I just wanted to try to tell my story. When I was a little girl, I was very curious, and I would take things apart and like my Barbie dolls and take their arms and legs off just to see how they work. So I was always very curious about things. So I also was into art when I was in school, and I liked to draw a lot. I was a Navy brat. My dad was in the Navy. I moved a lot. I moved, if you can see the map there, I moved from every grade, just about, I moved to a different school. So I had to really assess the environment that I was in and play catch up really quickly. And I had to learn, you know, very, very fast. And, you know, what I thought was interesting when I was looking back through my paintings and things like that, I always gravitated towards ships. So it must have been something foreshadowing that I would be working at a shipyard in the future. But, you know, when I was in fourth grade, we moved from California to Virginia, and they were just starting division in the 4th grade, and I moved. And then when I got to Virginia, they had already covered division. So I completely missed it. So again, I had to catch up very quickly. And I was kind of good at math, but not the best student. I was more into art. But anyway, I always had a will to succeed. I was voted quietest in high school. Very quiet person. And I also worked my way through community college. I couldn't afford school, and I was working at a fast food place, and I was like, what do I do with my life? I wanted to make some money. So, I said, I'm going to go to school and I'm going to be an engineer. I didn't know what kind of engineer, and I really didn't know what engineers did, but I knew I was somewhat good at math and science, and I was hoping to weave in some art there. And again, I meet these guardian angels. So the man in the picture beside me, when we graduated from Todreas Community, that was my boyfriend at the time, became my husband. And I remember I was thinking about electrical engineering because they made a lot of money back then. And so I said, I want to be an electrical engineer. And we had an electrical engineering lab. And I ended up, my lab partner and I, we built this circuit that had like 30 wires connecting it. But the goal was to light the light bulb at the end. And I lit the light bulb. So we got the grade, and then my husband happened, he's an electrical engineering student. He went by and he saw what we had done. He goes, what are you doing? And he pulled all the wires out and connected it with 4 wires and said, this is all you had to do. And the light bulb lit. And so I said, yeah, electrical engineering is not my strong suit. And I ended up going to mechanical engineering because I needed to see it. Mechanical, you can see things, how they work. And that's what I needed to do. So, I ended up going to work for a shipyard. They were hiring young engineers. It's called the Jonathan Corporation. It was in Norfolk, Virginia. And what they did at first was the president of the company said, you need to work down in the shipyard. You need to understand, you're coming right out of school. You need to understand what the parts of a shipyard are, how a ship gets put together, how you design, how you plan the work. And so I actually spent 2 years, down as a pipe fitter helper. Usually they'd make me sweep up stuff before I could actually touch a piece of pipe. But anyway, I ended up learning how to braze pipe and plan and design. And at the time, this was in the 1980s, there was something called CAD that was coming along, and our company actually bought a CAD company out of Boulder, Colorado. But I wasn't interested necessarily in using CAD. I was interested in how does CAD come, how does it work? How do you get the drawings, into 3D models, and how do you exchange data and all that kind of stuff? And so I was lucky enough to get involved in some CAD type applications, and I found another guardian angel. We had a contract to build a bridge called the Berkeley Bridge in Norfolk, Virginia, and they wanted to extend it 4 more lanes in the other direction. And who would think working at a shipyard I would be working, as part of building a bridge? But this person that I had worked with inside the shipyard, he was a production manager. He said, do you think you could develop some software program? This doctor has this PhD, has this idea of using weight and moment calculations to figure out how to put this V heating pattern along a steel girder, and that girder will bend. And we had all these girders to put into place to build that bridge. And so I had the paper, and I had done weight and moment calculations in the shipyard. So, and I wanted a program. So I learned how to program in the language that the robots spoke. And I was able to tell the robots where to put those little V's so they could heat and cool that girder so it would bend. And that was my first research project. And the first try out, the first girder worked. And it was like, yay, I was able to do it. So, you never know what's going to come your way, and you don't know who's maybe going to influence you or ask you about something. I would have never thought he would have said, hey, do you think you could do this? Because I had never programmed before, other than Fortran in school. But I was a quick learner, and I worked really hard. That ended up, but working with CAD and things like that, I was working on actual standards for CAD model exchange, and that's what led me to Newport News Shipbuilding. And, Newport News Shipbuilding is the largest industrial employer in the state of Virginia. 25,000, maybe 26,000 people. We're trying to hire 6,000 more people this year. They're the sole designer and builder of nuclear powered aircraft carriers, and one of only 2 shipyards that can design and build nuclear powered submarines. We have something called the Apprentice School. It's called the Apprentice School. It is a world class where you can learn, study, and also work in the shipyard and work on getting your degree. They help pay for your education there, and also you learn a craft at the shipyard. We have summer internship programs, co-op programs, entry-level positions. We've started hiring people right out of high school and train them. We have night school classes. That's how I learned a lot about the nuclear. There's a nuclear engineering like 101 class at the night school class. I took that and learned all about reactors and things like that. So we have a great education program at the shipyard. But that led me to some opportunities in modeling and simulation. So, you know, we at the time there were these things called virtual environments, and when we had these virtual environments, I love cats again, so I'm bringing in the cat story. And so I had to create an avatar, and I created my little avatar called Chester, a little orange cat. And I flew into all these different worlds, and I was like, I'm not sure I like these virtual environments because some people were mean to the cat. But anyway, I ended up going to the virtual, playing something called the virtual carrier, which is called a live virtual constructive technology where you bring in live assets and you link a bunch of different applications, hardware in the loop, software in the loop, and you simulate like the role of the carrier in wargaming type situation. So there might be something that we had a live aircraft, and we had somebody standing on top of our building holding an antenna, and we were getting live feed from that aircraft, and it was helping us. It was situational awareness of what was going on and what our carrier needed to do, what the aircraft needed to do to fight the mission or whatever they were doing. I built something called a virtual bridge, which was, you know, how are things located in the right place to be able to actually conduct your mission? You know, are the screens in the right place? Can you see out the windows? Whatever those things are. So it helped influence the design of the carrier. Another thing that the shipyard provided was there was a pilot program we wanted to try, which was engineer to sea. And I was in the pilot program. They wanted 2 females to make sure they could go. And we went on the USS Enterprise, which is the very first nuclear powered aircraft carrier. And, you know, we were there for modeling and simulation to actually time how long it took for an aircraft to you know, build the weapons, get the weapons up on the aircraft, a pilot to walk around his aircraft, inspect his aircraft, take off, you know, and carry out the mission. So we would do time studies so we could build that into our virtual carrier simulation. So very, very cool stuff that I've done at the shipyard that was very unique at the time. We were working with many defense contractors. So it was a wonderful, wonderful experience. And a lot of, you know, none of this is a single person. This is always a team. And I've worked with some amazing people at the shipyard. Also, as far as the nuclear side, you know, the virtual gaming environment was coming along. And so as far as training, how do you train people? You know, we have live drills, but how do you really train somebody if there's a nuclear spill or a nuclear accident? So we built a virtual environment where you could take on different roles and carry through with the emergency response that you might have to do in case of a nuclear explosion, nuclear spill. Safety training. So gaming, you know, that was new to the shipyard, but we took that on as a different way. You know, the people coming into the shipyard were gamers, and let's bring that into the training world to actually immerse people into those situations. And along the way, had some fun. That's a picture of me in my office there, looking out on the carrier right there. So in final thoughts, I just wanted to say, you know, along my way, I've looked back, reflected, you know, you want to seek to match your skills, your talents, and your passions, and be true and believe in yourself. Always believe in yourself. Be curious and open to different opportunities that may come along the way. Believe in guardian angels, because they do exist. There are people looking out for you. You wouldn't even realize that they're looking out for you. Talk to people and let them know what you're interested in so that they can help you on your journey. But most of all, find something that you really enjoy and have fun. So I want to leave you with one additional, thing you could try or think about for modeling and simulation and nuclear. So in April, it marked the 59th anniversary of the sinking of the Thresher. And it imploded under the sea, basically. It lost communications, and all 129 people on board were lost. So, Admiral Rickover, who's the co-founder of the Center of Excellence in 1983, he was the father of the nuclear navy and civilian uses of nuclear power. He created a fast recovery startup procedure because of this incident that allowed nuclear reactor to be immediately restarted after a scram. But, at the time they didn't have all this modeling and simulation, but think about today in a virtual environment, what kind of modeling and simulation could you use to help understand what happened? Because they didn't have a whole lot, but a lot of that information is being declassified right now. I saw that on the news and in the internet. It's just starting to be declassified over the last few years. So you can start understanding some of the problems they experienced during that time and what they think led to the implosion. My contact information is here. Feel free to reach out and talk to me, email me. I'm glad to talk to just about anybody about shipbuilding and modeling and simulation. There's a Newport News shipbuilding site there, lots of information about careers at the shipyard, and then the apprentice school, there's a link to that too. So that's my talk.
Thank you so much, Robin. That was really informative, and I've learned that, about way more careers in nuclear engineering that I wouldn't have thought otherwise, like gaming. I know a lot of people game, so there's an opportunity there for you, in modeling and simulation. So if you do have any questions about what Robin does, or just about Newport News Shipbuilding or her presentation, we have a Q&A function at the bottom of your Zoom screen. So after Dr. Todreas presents, we'll come back at the end of the event for a Q&A session. So please do put your questions in that function, and they will be addressed at the end. Thank you. All right, so at this time now, we're going to have Dr. Todreas come on and present. Take it away, Neil.
Okay, here we go. Welcome, everybody. Very nice to be with you, and Robin also. You'll hear from me a number of similarities with what Robin spoke about in terms of her experience. But of course, mine is going to be a little bit more on the academic side versus the construction side. So let's start, and Laura's going to turn the pages for me. So let's move to the next one. And I ask you, what do you see? What do these numbers refer to? And what they refer to is the Earth's mean temperature trend. Have you heard of that? Have you heard of global warming? Do you know the real problem we're having as our temperature trend goes up? Where, if you don't remember numbers, remember 1.5 degrees centigrade. That's the tipping point. That's what we've got to get to. And the reason I bring that up is nuclear power to produce electricity for the population here is a very, very important current moving issue associated with global warming. Because if we burn fossil fuels, coal, natural gas, of course, and all, we're going to keep having this mean temperature go up, and we're going to be into big problems. So that's part of my motivation. I didn't know about that when I went into nuclear to start with, but over the last 10 or 15 years, that's been a big part of my motivation in terms of work to develop nuclear power to fight global warming. So how did I get into this area, this STEM career? Well, first in high school, By the way, this is Admiral Rickover. I'll get to him in some comments that I'll lead on to. In high school, I took a Navy ROTC test, and I was fortunate enough to win a full scholarship for my undergraduate college career, which I launched. By the way, I'm from Beverly, Massachusetts, which is coincidental with my Navy experience through my lifetime. Beverly is the birthplace of the U.S. Navy. Of course, it's disputed by one or two other places, but I'm very proud of Beverly. During my college career, I took naval cruises. On one of those cruises, when I had a lot of time sitting out on the deck in the evenings when I wasn't on watch, I had a Scientific American booklet. Scientific America is a science engineering based magazine, which is still printed today. But that booklet was all about the promise of nuclear power. And so I spent 2 months going over that book, and that convinced me to go in to nuclear engineering. I started out as a mechanical engineer, and as these cruises went on and I got enthralled with nuclear, I took nuclear courses. And so when I finished college, I had a mechanical and a nuclear engineering degree. When I finished college, I went for another interview. This one was with this gentleman who you see, Admiral Rickover. His interviews were notorious for the way he conducted them. He was looking to try to upset the candidates, see if they lost their composure, or see if they could hang on and talk with him. So he had a tilted chair where the front legs were shorter than the rear legs. And so when you sat on that chair, you kept slipping forward. Well, I got through that interview and I got into his program, and I was in the Navy for 4 years. I had a few really interesting experiences. The next slide will show what I'm talking about. The first nuclear plant that was built in the United States was in Shippingport, Pennsylvania. And that plant, even though it was civilian, because Rickover had designed the power plant actually for an aircraft carrier, that carrier was delayed. So the plant was ready for use. And the president at the time was Eisenhower, directed that Rickover take over and build shipping. And I was in Rickover's office with 200 or 300 other people, and I was assigned and I worked on the core, the reactor core for this plant, which was first of a kind. Also, when I worked for Rickover early on, I was in my office one day, my boss came in and said, "Come on with me, let's get on this flight." Turns out we were going to Newport News Shipyard, which is the coincidence we have with Robin. I was working at that point of my career in Rickover's office on shielding for the Enterprise. That was the first carrier that was being built. So I got down there to see it. And I heard from Robin before we started that a new replacement version of the Enterprise, same name, is coming on soon. Again, of course, in Newport News. Well, after I finished undergraduate work, I went, and the Navy, I went back to MIT for graduate school. And I was hooked on the nuclear engineering. And so I went back and studied for a PhD in nuclear engineering, which I got after 3 years of study. Then when I started looking for a job, I got called from the people who I had worked with in the Navy who had moved into the civilian area. And so I worked for the Atomic Energy Commission for 4 years on innovative reactor designs. The work was stimulating, but at that point I got motivated that I really wanted to teach. So I spent the evenings teaching at Catholic University and the days working at the Atomic Energy Commission. After 4 years, I decided and went full-time into teaching. I was 35 at the time, 1970, and I went to MIT as a professor. I'm still here, by the way, and although I'm retired, I'm still here and actively working. So that moves us into discussion, what does a nuclear engineer do? Well, you heard from Robin activities in shipbuilding you can do, but I'll even broaden that. This is the gentleman, Enrico Fermi, who designed and constructed the first nuclear reactor. So obviously, nuclear engineers design and build reactors, but that isn't all they do. If we can move to the next slide, what this shows is the fundamental particles of radiation, alpha, beta, and gamma rays. If you go on to study, you'll see alpha, beta, gamma, those are the Greek letters that define those. And these particles can go through different materials at different thicknesses. But the main point I wanted to make is nuclear engineering is a combination of engineering and physics. In my studies, I took as much physics as I did engineering, and I have worked them together. So if we move on, the first thing then that nuclear engineers do is develop power plants. Now, what is this slide? This is the periodic table of elements, and this brings up the, okay, can we lift it up a little? We're missing a thing on the bottom, which is key. If you can't see it, I'll describe it to you. But, okay, let's just leave it with this. This is the periodic table, and to have nuclear power plants, fission had to be discovered. And what is fission? Fission is the splitting up of uranium atoms such that other atoms are generated, smaller ones. This is barium and krypton, typically, as two. And energy is generated because neutrons and other particles move off with fast energy, fast speed, and they can be slowed down and they give up their speed, velocity as heat. Well, fission was very, very unique when it was discovered in the 30s, 38, because all other chemical reactions before that, if you added a particle like a neutron, they got heavier. The evidence when neutrons were bombarded on uranium was that we got two lighter elements, barium and krypton. And the physicists of the world couldn't really comprehend that. It took a long time before people realized, even though in the particles that they observed, they saw lighter particles, they didn't know where these came from. They thought if uranium was to be bombarded with neutrons, the result would be a heavier particle rather than a lighter particle. And the picture that comes next is a picture of Lisa Meitner, who was a young Austrian physicist who, with her nephew, younger nephew, Frisch, she correctly interpreted the result as fission. The people who did the bombardment, Otto Hahn and Strassmann, did not figure out that fission had occurred. However, in an ironic twist of history, Hahn got the Nobel Prize for discovering fission, and Meitner got nothing except 10 years later recognition. So what does a nuclear power engineer do? First, works with power, but then also with medicine and science. If we can go to the next figure, this is Madame Curie. You might have heard of her. You likely didn't know what her real last name was, her maiden last name. She was a Polish young lady. She went to school in Warsaw, then went to Paris, went to college there for a PhD, and she married a Frenchman. His last name was Curie. So she studied science, and she, in terms of medicine, she won a Nobel Prize in chemistry in 1911 for discovering radioactivity, and won a Nobel Prize in 1903 in physics for working with radium. And she also pioneered the fact of imaging. Right now, nuclear engineers work on imaging. That means pictures like X-rays, but we're beyond that now, and we're into nuclear magnetic resonance imaging. So those are the three things a nuclear engineer can be: in power and in science. Engineers of all disciplines become nuclear engineers. So you can be a mechanical engineer like I was, chemical, electrical, or materials science. And with that spectrum of activities and capabilities, you have multiple job offers. In fact, I've had students, because of their mathematical and analytic capability, are working on Wall Street doing risk analysis and financial gamesmanship. So now, what does a nuclear professor do? Teach, research, write papers and books, and importantly, give lectures to the public about energy, radioactivity, and nuclear power. So if we go to the next slide, you may recognize this guy. This guy is Bill Gates. You think of him in terms of computers, but in terms of research, he has sponsored and has decided to work on and launched a project to build the next innovative nuclear reactor, a reactor cooled by liquid metal sodium and of a spectrum that is unique. That type of reactor was the first reactor I worked on in terms of research, and Gates has stepped in now to commercialize it and enhance it. It has some advantages over the existing reactors, but together with the existing reactors and hopefully building Gates's sodium reactor, will have nuclear power going on. Now, you've learned a few things, I hope, through the lecture. There's one other one now, and that's the word natrium in Greek, and that stands for sodium. And sodium is the coolant of this Gates reactor. The last slide I wanted to show here is a fusion device. This is a fusion is on the other end of the scale from fission. Whereas in fission, you break up the uranium atom into smaller pieces. In fusion, you take two particles and they combine. And fusion is very, very, of course, that's how the sun generates its energy. And we've been working on it for a long time, but we've just had some breakthroughs in the design of fusion reactors, and we hope they'll come online and be in place to help us combating global warming. However, that's going to be a tough task to accomplish. So I'll close with two things. First, what skills should you develop to be a nuclear engineer? And then a little career advice. So in terms of the skills to be developed, math and science, of course, are first. But then, and you've heard this in other lectures of this series, which I've listened to too, the ability to communicate is key in any activity you get into, but particularly in engineering and technical activities. You got to communicate to your coworkers and to the public. Then you've got to work in groups. You got to work effectively. You can't work just as a loner. You need the guidance and the assistance of others. And finally, under skills, I'll put you should have breadth of interest. That's the way you can appreciate what's going on in the world, and you can understand things like the environmental crisis that we're facing in the future. As for closing advice, 3 points. Closing advice as you pick and work on a career. Work on important problems. Don't spend your time on things that don't matter unless they're building blocks to enable you to learn how to work on important problems. Second, challenge yourself to grow your skills. Don't be complacent. Don't lean back once you finish some educational activity. Take the next step and grow your skills. And then finally, you see the words there. This is the same thing that Robin was actually talking about in terms of guardian angels and the people she worked with. Find and work with the best people you can, because that's how you learn new things and you advance yourself in whatever career you decide to undertake. I'll close with that and let Laura pick up.
Thank you so much, Dr. Todreas. That was very informative. I definitely learned a lot. But also as a chemistry teacher, prior chemistry teacher, I love hearing your small introduction to alpha, beta, and gamma rays, nuclear reactions, writing them out and balancing them is one of my favorite things to teach, or was one of my favorite things to teach as a chemistry teacher. So thank you so much for your presentation.
That's fine. Love barium.
Yes. All right, so at this time, we are going to open up the event for Q&A. I can already see that we have some questions, and I will facilitate that. But as the Q&A session progresses, if you do happen to have any questions, please do not hesitate to add them to the Q&A function below. So the first question that we have, and I have some of my own to ask, but the first one that we see in the Q&A function, I guess can go to you, Dr. Todreas. It says, or, Robin, if you want to answer too, what are your views on the future of thorium-based power as a substitute to uranium?
Thorium has been promoted by a number of organizations, but thorium doesn't have a real advantage over uranium. It's sometimes promoted in terms of proliferation resistance, but if you look into that in the detail, it is not. So I don't think thorium will take over. That's unfortunate news for the Brazilians, who have a lot of thorium in their ground. I would love to sell it, and also the Norwegians, but I don't think it's the savior.
Thank you, Dr. Todreas. And I also wanted to, this is my own follow-up question to that, because I know you brought up a commercial fusion reactor that's in the works, being developed. Can you talk more about I guess, what the pros are of using fusion nuclear power as opposed to fission, and why we're working so hard to accomplish that?
Yeah, the big reason, the fuel for fusion is deuterium, which is heavy hydrogen. And everybody in the world who's on the sea has access to that fuel. So that's one advantage. It increases that aspect of it. It also, because the fuel is not uranium, and you don't wind up with smaller atoms called fission products, the radiotoxicity of fusion should be less, but it's well overblown, because fusion reaction creates neutrons, and neutrons move and can cause structural materials to become radioactive. You don't get away free of radioactivity in the fusion reactor, but it should be less of a burden. Those are two big factors. I don't think it'll be cheaper though.
Yes, I'm sure it's very expensive. Thank you, Dr. Todreas. I have one question for you, Robin, before I refer back to the Q&A function. You mentioned how a lot of the large number of the people that you work with too are also gamers in their everyday lives. Do you know what their background was, or like if you have an idea what their background majors are? I remember my school had a major in interactive media game design, IMGD. Do you know if any of them that was their background, or they had engineering backgrounds and just happened to have like a hobby of playing video games as well?
Yeah, that was more like it. I mean, we had just started getting into gaming and virtual reality, augmented reality, those kind of technologies. So a lot of the people that had been at the shipyard for a long time were starting to develop that technology. They were familiar with that kind of software and hardware that you needed to build that. We started within those programs, though, hiring, they have to be 18 years old, but high school, right out of high school, because we wanted those people that were gamers that came with a fresh outlook to help us come up with ideas and you know, as a new person coming into a shipyard, what are the things you have to worry about as far as safety and things like that. So they helped influence a lot of that. But like I kind of talked about with my journey, I didn't know what I was going to be when I started out. You know, I was a mechanical engineer. I thought I was going to do mechanical engineering stuff, and I ended up being modeling and simulation and a programmer and data analyst and all that kind of stuff. So the world is your oyster, basically. You like something, you learn it. And that's what we do here at the shipyard is we teach you everything. If you want to be a nuclear engineer and you don't have that background, we start teaching you all about nuclear engineering, so you understand all the safety regulations, all the quality regulations, to handle nuclear material. So, you know, it's amazing the different people we have, the different careers that people have. Every time I talk to somebody, it's like, you started out what, and you're doing this now. So it's just open to everybody. That's all I can say.
Yes, definitely. I think people should understand that STEM skills can definitely be built and worked on, and you can always grow and learn. So thank you for that, Robin. Our first question here that it says, as a high schooler interested in chemistry and physics, is there a way that we can get real world experience with research? I know that's very broad, but if any of you all have any ideas about how any students could start getting involved with research, even at high school, at the high school level.
Well, I know that there are a lot of summer programs offered. In fact, your organization, Laura, has a program for high school juniors in the US and throughout the world. However, in fairness to answering for the student, that program is an elite program, takes 60 US students through the whole program, and they're very tough. So what you need to do is go online and search your local college, community college particularly, and you'll find that summer research programs are offered to varying degrees, of course, for high school students at universities. Don't be afraid the fact that you're a high school student, because the colleges and the universities want to get good people to apply for their regular programs, so they'll start with high school students, motivated high school students. So show your motivation by going on the web and looking really hard for such opportunities. Then, of course, if your friends or your parents have anybody who's working in an area like this, see if they can give you some leads.
Thank you. And this might tie into the question that says, what should one do to have the most impactful nuclear engineering career?
Well, I would dispute that at the beginning, that there's one direction that's most impactful. As I thought I said, whether you're dealing with power, medicine, or science, nuclear engineers can fit into any of those. And if you're dealing with power, you can be a nuclear reactor physicist, or you could be a modeler or a simulator, and you can have an impactful career. Modeling and simulation, my experience, and I see this now, is that's really a hot area, and it's all over. So you can be very impactful across the spectrum. It's what you produce and your energy that you put into.
Thank you. Robin, I don't know if you wanted to touch on that too.
No, I agree with that. You know, when I was doing research, I was always, you know, reading on the internet and learning about stuff, and I would read more and more and more. And so, you know, it just starts with, you know, the more you read, the more you start understanding. Believe it or not, all of a sudden you start finding contacts that are local, and then you just find opportunities that might arise. So there's so many things that you can do today with, being online on a computer. Back from when I was, around, there wasn't any internet. So just use the resources that you have and study hard, and you'll start making contacts. So that's about the best advice I can give.
Thank you, Robin. The next question is, are the safety benefits of small modular reactors great enough for us to completely stop using traditional reactors and start to completely rely on small modular ones?
Okay.
Once we start using them, is it more beneficial to just start using small modular reactors instead of the ones we currently use?
Yeah, okay, there's two parts to this question. The motivation for small modular reactors is economic, as well, to some extent, with safety. The economic factor comes from the fact that the reactor isn't so big, the construction isn't so complex and difficult, so you can make these reactors smaller. They will be cheaper than a large reactor, but that's total cost cheapness. The other thing on economics is, though, the cost per kilowatt electric will be more for a small modular reactor because you're not producing as much power. Safety-wise, yes, the small modular reactors have some advantages safety-wise, because there's not as much radioactivity, not as much structure. You can get coolant into them. But the safety record of large reactors in the US, particularly since the 3 Mile Island event, has been very good. So I don't subscribe to the fact that small modular reactors should take over from large reactors because of a decided safety advantage. I think the issue will be decided on economics, not safety.
Thank you, Dr. Todreas. The next question, I guess, for both of you, do you have any reading suggestions for a high schooler who enjoys math and physics, but isn't sure if nuclear physics or engineering is a good fit for them?
Did they say what type of reactor, or what type of reading? This is
they
hardcore,
just enjoy
non-fiction?
math and physics, but no, they didn't specify, but they're not sure if nuclear physics or engineering is a good fit, but they are interested, but they do enjoy math and physics. Can you think of any reading material?
Well, I mean, I don't think of anything specific to that. Of course, on the one hand, you read science fiction, and there's all kinds of math and physics implications and approaches done. But readings of math and physics, no, I wouldn't think it's particularly in books. It's in doing. Try to go and get some work exercises doing math and physics problems, and see if you like that kind of thing.
Yeah, I can't think of anything either. I know that there are a lot of like science news websites that you can find current, just developing trends in different fields in STEM, and you might be able to read about math and physics news or new innovations. And I don't know, that might inspire you to go into nuclear physics and engineering, but I can't think of any specific reading material from in my mind on the top of my head.
I'd add one thing. Pick a discovery. and then go read about that discovery. So that's what I was trying to get to. Read about the discovery of fission. Read about the discovery of radioactivity that Madame Curie did in radium. So get real life or stories of real life discoveries, because these discoveries didn't all take a smooth path. Most of them did not. There were surprises, insights by people, and I'm sure some of these written histories would have those in there, and they would be inspiring and educational.
All right, we have a few more questions before we wrap up. Are there nuclear reactors that can directly convert the energy from a reactor to electricity without using thermal energy as the method for generating electricity?
Yeah, no, I know that that question well. The answer is no, but that no is not written in stone. There have been approaches where you try to do just that, and you need certain characteristics of materials and reactions to do it. That, on a small scale, that transformation will probably be achieved over the next 10, 15 years in the advance of science. But we don't have reactors that can do that now. And there's big implications. In fact, we don't do that because of thermodynamics. We have to dissipate heat. And that means we have to site the plants on oceans, ponds, lakes, rivers, etc. So it would be a great advance if we could achieve what the questionnaire asked.
If students are interested in nuclear engineering, what's a good starting book? You can think, not that's okay. Maybe Dr. Todreas, since you teach nuclear engineering, you know, like an intro to nuclear engineering book.
Yeah, but the ones I know are at the college level. Go back to 1958 and get the Scientific America book on nuclear energy. Of course, you're not be able to do that, but the analogy to that is not in books, but in magazines and journals. There are information about different directions and different types of nuclear approaches. If you want a book, then a guy named R. Kneif, Kneif, who used to work actually at the parent company of 3 Mile Island. After the accident, he worked there. He wrote the basic undergraduate book on nuclear power, which if you've got any kind of a engineering background, you can understand. And if you can see me, it's about that thick, about 2 inches thick.
I think I found it on Amazon. I'll put it in the chat.
Yeah, I'm just looking for it behind me.
That might be it in the chat. But our last couple of questions, we have one question that says, and I feel I have my own opinion on this, but I'll leave that to you, Robin and Neil. If you get a B in math, is this a good indicator that you should pursue? Is this not a good indicator that you should pursue nuclear engineering? You get a B in math.
A B in math?
I can say from myself, I've had to answer a lot of complex and work on a lot of complex problems. And I wasn't an A student in math. And it kind of depended on the teacher. And, you know, if what I always believe is if you have a mind to do it and you set your mind to it, you can do anything. So don't let the grades get to you. It's more about what your ability and what you can do with the information and applying it. I mean, academia is one thing, but applying the math in real world, that's really what it's all about.
Yeah, I'll add in that same direction. to me, what's more important than math is intuition and creativity. And of course, an ability to think in terms of quantitative, scientific approaches. So if you can create concepts, ideas, approaches, the math helps you work them out. And that's the second step, but it's not necessarily the first step. You got to be creative and you got to be hardworking first, as far as I would see. And I would just follow up. Math is something you can always improve on if you've got a good teacher. Since it's logical, if you got somebody who can explain it well, you'll be able to pick it up. So go back at it.
Thank you, Robin and Neil. Our very last question, I think I can direct this to both of you since you both have extensive experience in nuclear engineering. What are the negatives and positives in nuclear engineering that people don't talk about often? Or I guess another way of putting that is, what are the misconceptions that people have when they hear nuclear engineering? And how do you all work around those misconceptions?
Well, let me start. Look at the thing about nuclear engineering with the misconception is people are scared stiff of radiation. And they link radiation, and it goes back to the atomic bombing. And that's the starting point. The misconception is that any amount of radioactivity is bad for you. And there's, in fact, a whole movement and scientific thrust for something called hermeosis. And that is the idea that a little bit of radiation is normal. I mean, in fact, if you eat bananas, you have potassium from bananas in your body. If you're sleeping with your wife next to her, you're getting some radiation from the body of another person. And so radiation in a small amount is not bad for you. So this idea that any radiation is bad is incorrect. What people are working on now is trying to quantify just where this boundary line is. But don't be afraid of radiation per se. A little bit is okay, and we know how to manage and control it now. I'm sure in the shipyard, every time I've been there, there's radiation controls, very strict on workers on each job. And so there's very good attention in any job in this industry on controlling and working safely with radiation.
That's true. And I would echo too, that's one of the benefits of using modeling and simulation. You can experiment with different things and look at the positive and negatives and get some data, real data behind it.
Thank you both so much. That is our very last question for tonight. So let me just share my last slide. Thank you to all of our attendees for joining us today. I also want to thank Dr. Todreas and Robin Penley so much for their wonderful presentations today and helping us learn a little bit more about nuclear engineering and all the possibilities of nuclear engineering careers. We are recording this event and we will send a notice when the recording is available. All attendees will also receive a certificate of attendance for today's event. And if you haven't already, please register to join us for next month's STEM Lyceums event. And the theme will be the Internet of Things in Healthcare. So you can register on our website if you haven't already. And if you have any follow-up questions about today's event, you can feel free to email me. My email is on the screen. But other than that, I want to thank you again for joining us today. And I once again want to thank our panelists, Dr. Neil Todreas and Robin Penley.